two charges exert forces on each other. If both Q1 and Q2 are positive, the electric force is repulsive, so the electric force is going to point rightwards in this picture. And in this picture, the displacement, dr, is leftwards, so they are anti-parallel. Cosine of 180 is -1, so you end up with a negative work done by the electric field, positive work done by the external agent. If the two charges were oppositely charged, if one was positive and the other was negative, and it doesn't matter which, then the movement from Ri to Rf, in this case, is going to be parallel to the electric force, and therefore the work done is going to be positive. So if we allow these things to move freely, spontaneous motion, like charges are going to spontaneously move apart. That's the field doing positive work. Opposite charges are going to spontaneously move together, and that is the electric field doing positive work on the opposite charges. So the sign of the charges matters. So if we take a look at the graph of this, for like charges, the potential energy is positive and approaches infinity as R approaches 0. And again, this is the classic sort of, there's a hole in my theory. And ultimately, we have to figure out why it is either impossible for R to actually be 0, or we have to account for why this potential breaks down. And the opposite is true, as the unlike charges, R approaches 0, U approaches negative infinity. And again, the same thing. Hole in the theory. How do we fix that? Quantum mechanics.